Imagine walking outside tomorrow morning, looking at the horizon, and seeing two distinct, brilliant suns rising side by side. The global confusion starts as a debate over rare atmospheric reflections, but as camera feeds flood the internet, that curiosity quickly turns into a cold, scientific panic. Space agencies around the world soon confirm the impossible. A massive wandering star has entered our solar system, drifting close enough to disrupt everything we know about our orbit. For 4.5 billion years, our planet has relied on a single star for every calorie of energy and every degree of warmth. That long era of stability is now over. The assumption that our home was permanent has been destroyed in a single morning. Stars travel through the Milky Way at hundreds of thousands of miles per hour. While the void of space usually keeps them isolated, stellar wanderers occasionally pass through populated systems. This diagram shows the intruder's path. It doesn't need to collide with us to be lethal. By piercing the outer planetary orbits, the star's mass begins to override the sun's hold on Earth. The second sun grows brighter every hour. This intensity comes from the rapidly closing physical distance between our worlds. The star's immense gravity is effectively pulling Earth away, beginning the process of stealing us from our home system. Caught in a tug-of-war, our sun pulls from one side, the rogue star from the other, stretching our orbit. This instability randomly shifts days and seasons. Competing forces pull the oceans, creating massive tidal waves on opposite sides. On the surface, these tidal disruptions result in coastal flooding on a scale humanity has never seen. The very water we depend on for survival is being dragged across continents by the weight of two stars. We are violently moved out of the only stable orbital pocket life has ever known. As the rogue star wins the tug-of-war, Earth drifts further from our sun. The temperature begins to fall immediately as we leave the habitable zone. A global freeze takes hold. Agriculture fails in the tropics. Cities struggle to stay warm, and energy production cannot keep up. Week by week, the yellow sun we've known for millennia visibly shrinks. It fades into a distant, cold point of light, no longer capable of sustaining the surface ecosystem. Without our star's thermal output, the planet faces total ecological collapse. The world we knew is dying before we even reach our new destination. With the surface becoming uninhabitable, global governments are forced to cooperate. As the population retreats into deep Earth bunkers, an armada of space probes is launched toward the incoming star. These probes are searching for a miracle. Scientists calculate if Earth will settle into a new habitable zone once capture is complete, or if we are destined for permanent ice. The goal has shifted from saving the old world to a desperate gamble for survival in a new one. A moment of wonder. Months later, the orbital chaos finally ends. The survivors emerging from deep Earth shelters find that Earth has settled into a permanent orbit around its new host. The night sky looks like a different dimension. Our sun is now just another star in the distance. The horizon is dominated by unknown planets, including a massive ringed gas giant that now hangs over our world. Deep space sensors reveal that this rogue star brought an entire system with it. We aren't alone in this new orbit. Scientists identify a nearby rocky planet with a thick atmosphere and chemical signatures suggesting liquid water. For the first time, another habitable world is within our reach. The violent relocation was catastrophic, but it placed Earth in a neighborhood rich with resources and new worlds to explore. It provided a second chance that would have been impossible in our old, isolated system.
Current astrophysics shows that a direct planetary capture is exceedingly unlikely. The space between stars is too vast for these encounters to be a common threat. Still, gravitational interactions and planetary thefts are real. They occur frequently in dense star clusters, where the proximity of thousands of stars makes orbital stability a luxury. This thought experiment highlights the fragility of our reality. Every memory and warm afternoon exists because of the quiet stability of our one sun. If you had to choose, would you stay with a familiar but slowly dying sun, or follow a new star into an unknown future? Let us know in the comments by typing "stay" or "leave." Subscribe to Future Decoded to explore more cosmic possibilities, because sometimes the universe moves us to give us a new beginning.